Hey makers, welcome back to Hub360 Embedded Sphere. If you are into microcontrollers, you have probably heard of Arduino Uno and ESP32. But today, I want to introduce you to a powerful board that deserves way more attention, the Raspberry Pi Pico. In this tutorial, we will get started with the absolute basics, blinking an LED. It's simple, but it's the hello world of electronics. And by the end of this video, you will understand why the Pico is an incredible addition to your Maker toolkit. So why should you care about the Raspberry Pi Pico? Let me give you compelling reasons. First, it's incredibly affordable, that is cheaper than most Arduino boards. It's powerful. The Pico runs on the RP2040 chip, a dual-core ARM Cortex processor running at 133 MHz. It has 264 KB of RAM and 2 MB of flash storage. That's serious processing power for the price. And also it's flexible. You can program it with MicroPython, C++, or even CircuitPython. If you are coming from Arduino, the transition is smooth. If you prefer Python, you are covered too. For this tutorial, you will need a Raspberry Pi Pico board, a micro USB cable for programming and power, one LED, one 220 ohm resistor, two jumper wires, and a mini breadboard, and also a computer with Tony IDE installed. It's free and works on Windows, Mac, and Linux. You can get all components at hub360.com.ng. Before we dive in, let's quickly understand the Pico's layout. Don't worry, we'll keep this simple. The Pico has 40 pins in total along the edges. You will find 26 GPIO pins. That's the general purpose input-output pins. They are all your digital pins. It has 3 analog input pins, about 8 ground pins labeled GND, power pins, that's the 3.3 volt output, and a V-bus for 5 volt output. For our LED, we'll use GPIO 15, this GPIO 15, and any ground to complete the circuit. One important note, the Pico runs on 3.3 volts logic, unlike the Arduino's 5 volts. Don't worry though, our LED circuit works perfectly with this. Now we'll connect the LED to the Raspberry Pi Pico. First, connect the positive pin of the LED to GPIO 15 pin of the Raspberry Pi Pico. Next, we'll connect the negative pin of the LED to 220 ohms resistor. And lastly, connect the other end of the resistor to the ground of the Raspberry Pi Pico. And that's it. Before we dive in, let's quickly understand the Pico's... Alright, let's set up our software. We are using Tony IDE because it makes working with MicroPython super easy. Step 1. Download Tony from tony.org if you haven't already. Install it like any normal program. Connect your Pico to your computer while holding the boot cell button. You will see it appear as USB drive called RPI-RP2. If this is your first time, in Tony, go to the bottom right corner where it says Python and click it. Select MicroPython Raspberry Pi Pico. If this is your first time, Tony might prompt you to install MicroPython firmware on the Pico. Click install and wait about 10 seconds. Once that's done, you will see the MicroPython prompt in the shell window at the bottom. Type print hello Pico and press enter. If you see hello Pico printed back, you are ready to go. Time to bring this live with the code. In Tony, let's write our first Pico program to blink the LED. Let me explain what's happening. The while true creates an infinite loop. This code will run forever. LED.value1 sets pin 15 to high. Turning the LED on. LED.value0 sets it to low, turning it off. The sleep 1 pauses for 1 second. Now click the green run button or press F5. For your code to work perfectly fine, it's advisable to save this file as main.py on your Raspberry Pi Pico. And that's it. Your LED should be blinking on and off every second. The possibilities are endless once you understand the basics. Now, how does this compare to Arduino or ES32? The Arduino Uno code will be almost identical, just using digital write instead of LED.value. But the Pico gives you more processing power and memory at lower price. For the ES32, it wins if you need the Wi-Fi and Bluetooth in every project, but the Pico W gives you wireless capabilities when you need them, and the standard Pico is perfect for offline projects at a fraction of the cost. The Pico sweet spot, it's ideal for battery-powered projects, low power consumption, multiple sensor projects, it has plenty of GPIO pins, real-time application because of its dual-core processor, and learning because it's affordable enough to experiment without worry. The Raspberry Pi Pico is an incredible versatile board that bridges the gap between simple Arduino projects and more complex Raspberry Pi systems. And honestly, it deserves more love in the market community. And that's it, you have programmed your first Raspberry Pi Pico project. I hope this opened your eyes to what this little board can do. If you found this helpful, give it a thumbs up and subscribe for more tutorials. I'll be covering more Pico projects in upcoming videos, including sensors, motors, and wireless communication. Drop a comment below and let me know what project do you want to build with the Pico. I read every comment and your suggestions shape future videos. Thanks for watching and happy making. This is Hub360 Embedded Sphere, helping you bring your ideas to life.